Here we are at one of the Ceado plants with our good friend Cosimo Libardo.
Hello.
Who's taking time out of his hunting trip to show us around today. So do you want to start at the start?
So this is what we call the burr factory. In reality, we do a lot more things than just burrs here. We actually manufacture the whole grinder in a way and sort of couple it together to measure and see tolerances and everything works together the right way. So we have a number of tooling machines over here. On the wall on to our right, this is the journey to flavor, because Ceado doesn't just make grinders, we make flavor tools.
Does this come off?
So, I don't think so, no. It's glued. So, this is the rod of metal, you'll see it inside. This is a slice when it's sliced. Then basically we have a tooling machine that creates the holes and sort of creates that inclination in the middle, where this is where we're gonna then cut and make the burr, which is the next stage. We carve the different geometries out of the burrs. Now at this point, the metal is still soft, so if you try to grind with this, will last nothing. It's not that soft. And then we send them to the hardening process, and at that point, the metal becomes super strong. Then we have a way to level the burr in order to give a consistent grind. And that's because burrs get deformed during the hardening process, so you need to flatten them again using different processes. And then there are all these different coatings and all these different geometries that are supposed to bring a different type of flavor out that we apply to different grinders. So the burr is basically part of the grinder project as a whole. I see a lot of people changing burrs from grinder to grinder, expecting, just a different flavor, but the push of coffee out, given the RPMs you have, is very different. So you get a completely different result.
So,
also
the
physically, the clumping, you could have regrinding, clumping, so it's not just a matter of flavor.
Like putting a striker in a football team?
Yes, you need to have the right striker for the team. Okay, here we are at the cutting station. Normally we cut the rods for burrs, but here you see something very special. This is the head of the Rev series grinders. It's a full block of aluminum. This is the rod where we cut it from. So this is the slicing machines where we take these big chunks. Then this piece will be taken to a carving machine that will create basically the head for all the Rev series grinders, which is a 2.5 kilo mass that we have around the burrs to keep them stable for temperature. This is the body of the Rev steel. Same process that we use. This is a full aluminum block where we slice them and then tool them in order to have all the screws and all the inserts to attach. And this is how we build the Rev steel. So this is efficient from a manufacturing point of view. It allows us to have different sizes.
Yeah, so it's
for
instead
the
of
body.
using casts and molds.
So instead of making a mold, what we do is, yes, we have this longer tubes, let's say, of aluminum, and then we cut them because the Rev Titan and the Rev Steel are shorter. One is longer and one is shorter. So basically we're able to do two bodies out of this system. Wow. Which makes it very efficient.
Cut me off a piece of grinder there, and it's just like
we slice grinders here. We make burrs and slice grinders.
It's like on a meat slicing machine. And this bit's really interesting here with the. I never thought of burrs like this before. They're like you have a giant stick of burr.
See, that's what we're doing here. This is interesting to see. This is the machine that we use to slice the tubes that you saw there into the grinder body. As you see, this is the raw finished part where it needs more tooling.
Two different sizes, is it?
Yes, because the Rev Titan and the Rev Steel have two different heights. So basically that's why we use this method. So it's very efficient that way. And here you got the rods that we use to make the burrs.
It's a big stick of burr, basically.
Yeah. So yes, there were burrs of different sizes. The 64 millimeter. This is we use for other parts of the grinder. And then this is because when you say making the burr, we actually make the whole grinder, from molding to cutting to finishing, tooling. Everything is made internally. Everything that Ceado does, 90% of our grinders are made in here. So,
and because you use processes like this,
yes,
you can do things faster as well, because you don't have to create a mold and then cast it.
It's faster, efficient. Also, we can measure the tolerances because having a bird that is super precise on a body that doesn't have the same level of precision and the support that we can't control. Here we measure everything together as a finished product and we see all the tolerances. Wow. So it's high precision, so to speak. It's not like, it's more of a process of making watches or engines than the process of making espresso machines here. So that's what we do. So anyway, you have metals of different alloys depending on what you want to do. So we have a softer metal for cheaper burrs, let's say, the grinders that are price oriented. For the Rev series, we use the K110, which is the hardest type of metal that as a base you can use, on which then we can apply the coating. And with this kind of steel, we get the coating to penetrate even deeper inside the metal, because when you do the coating, you form crystals of it that are a new chemical compounds that penetrates deeper into the base. And that makes the metal, the burr, last a lot longer. Because you can apply coating on a very soft metal and they don't, the coating, the burr looks outside the same color, but in reality, the duration of the burr is half or 1/3. So that's an important factor. The base where you apply the coating is very, very important. And we use the highest grade materials for all the Rev series and the Ceado in general as a brand. And here, what we're doing now, see that you saw those blocks of, these were the two parts that you saw earlier. Yes, before, yes, this is the final result.
Wow.
And this is the top. So the two pieces go together.
Amazing. And
this is the 2.5 kilo grinder head. And these little lines here are for airflow. So we have a funnel at the bottom that sucks the air from a grid at the back of the grinder, and we create airflow. So it's like the piston of a Moto Guzzi, you know, the piston head of a Moto Guzzi, where you get air continuously extracting heat even inside the grinder. So this is outside.
You want to do it at the right rate. It can't be too much or too little.
Yes. So we control actively. You can actually set 3 different speeds for the funnel, for the fan to suck the air through those surfaces.
The grooves.
And so you can cool faster or slower. So we don't believe, I mean, a fan doesn't cool down a grinder. Because the fan has a power, the biggest fans you can use for computers, they can give you maximum, I don't know, 22 watts. Consider that a grinder motor for a Titan is 740 watts.
Yeah, it's not touching the sides.
45% of that becomes movement, 55% of that becomes heat. So imagine you have over 400 watts of heat produced instantly, and a grinder of 22 watts should cool it down. There's not enough energy to compensate. So when you see grinders that tell you that where they use the fan to cool down, yes, over many hours when the grinder is not working, they will. But what works really well is isolating the masses. So for instance, this grinder also has the motor is separated from the burrs. So there is a transmission. And there is also insulation. I'll show you at the factory later, the whole part finished. But this is what it's going to look like. So all these pieces of metal are carved out here together. This is how the burrs start. They're like this. You got the raw base, and this is the result at the end. I need to be very gentle because these ones, they fall, obviously they're no good, but even with transport, the burrs can change some microns. Any burr out there can change some microns in tolerance, so you got to be very careful how you handle them. Now these are soft and need to be finished, but this is the result of this phase. So this is before and this is after the robot is done. And we engrave all the codes on the side of the burrs as well with the laser engraving, which should be happen soon there. We're even cutting this. This is the head of the E37Z Barista. So there is no robot that is designed to make burrs. We have to commission them. And so we have 2-3 people in this business that know a lot about making burrs, that have basically designed all the processes and program all these robots to do this stuff. So this is the head of E37Z Barista. This is where the display goes, and this is how it attaches. Obviously, this is coming from the injection molding for aluminum, and then we finish it here and carve it and tool it here. This is a very cool phase. This is where we do the flattening So I suppose we have a geometry that we're testing now, and we have a few burrs. This is a blade that is now grinding the top of the burr. And this liquid that you see here is because we're avoiding sparks. So this is glycerin and water mixed together, and it keeps the process without sparks and sort of the temperature lower because the metal is under a longer stress. This plate that you see underneath is magnetic. So the burrs are like stretched on the plate, and the top is flattened to get the same exit. For the finishing, exits are very important because the grounds are very even that way. This is one of the most important tools. When I said we have the tolerances, we measure the tolerances of everything. This is, for instance, a rowboat. It's called Hexagon, and this robot, what it does, measures all the components that we put in the grinder. We measure their tolerances, and when we couple them together, we understand what level of precision there is. This is the collar that is the top of the Rev series here that we're measuring. We sample out of every production batch a certain number just to see if they're within the tolerances we program for them to be. So this is because having a burr on a surface that is not aligned or having a surface that is uneven around the burr will affect the output of the burr.
Yeah.
That's why I say burrs are not just a thing that lives on its own. They need to be part of the same flow. They're part of the same system, just like the striker.
Like a striker on a bad football team.
Oh,
Yeah.
a striker on a bad football team, doesn't matter how good it is. I don't think you've seen the plant in full swing like this before. No, like with all the parts that we make here, because when you came last time, I think
There was
we were
definitely less
making
machines.
Yeah, see, there is more machines. Yes, that's true. Tooling machine is what we use to make. This is the knob of the rev steel. This is how we adjust basically the grinding, and it's connected to the encoder that transfers the rounds to the screen, so you know what setting digitally is. It's a special design. This also is important because the tooling and everything for dismantling, also when you need to reset the burrs, this is a special design that allows you to do it pretty easily. There's a lot of research in this. So this is what we're doing here. We're taking this piece that has got to this level of preparation, and then we carve out everything in order to create this. This is the housing for the burrs. This is what makes the burrs spin, and these are the wings that push the coffee out to reduce retention. So this is the design. It's a specific design for the Rev series. And this tells you, like, there are no screws, nothing. See how this rotates with low friction. This is precision.
And fun.
The stuff we carve out that we recycle. So aluminum, you can melt it again, right? So this doesn't go to waste.
You just send it off and they
yeah, they melt it again. Yes. That's why we collect everything here. And that's why we use aluminum for a lot of parts. Great conductor, solid. I mean, we make steel parts in the grinder, but obviously you want to have, this is super easy to melt and recycle. All the water that we use for the thing is filtered and recycled. We use it so many times. Yes, with the same water, with sort of a laundry machine there that sort of filters it, cleans it, and then reuses it. So the water you saw for the burrs that we use, the glycerin water, is used many times, otherwise it will be a huge waste.
Yeah.
Here we're punching holes through the bottom of the Rev series grinders. I mean, I don't know if you've looked inside, but this is pretty interesting how the tooling works. Go close because you can't see it. But how the machine moves things. The housing that we use for the load cell. This is the load cell, the modular weight control system. This is the housing for it. This is where the load cell goes inside, so it's all protected.
Mechanism yourself.
Yeah. And then this is the cover for the WEM.
Wow.
It's all made here.
Nothing off the shelf.
There's not a single thing that we don't make. Yeah, it's not just about making the burrs. We make the whole thing. Because I don't think that's what I don't think people is getting, is what it takes to make a grinder and to make a grinder together. in the same place. This place is getting busier and busier because we're adding machines. We're going to run out of space very soon. Like, look, this looks like a...
But the whole thing has to work in cohesion, all the small parts together.
Yeah.
Like a football team.
Yes, the football team is important. Here we have the whole body of the rev grinders that is getting holes punched through for the screws, so that we need to couple things together. There is the housing for everything. This is a Japanese tooling machine that we commissioned to do all the work on the body of every grinder that we make, so that all the programs are loaded inside. And it looks a bit like an astroship. Look at this. It's a spaceship with a console to drive it. So earlier, Fabio, which is our expert, was just trying to give different intensity to the tools, just to test some stuff that he was testing before. The machine has done its job. So all the holes are punched. This is after this machine, this is what you get. This is the end of the tour of the tooling factory, where we couple everything together. Now we go to the other factory where I'm going to show you the finished product after it's assembled.